In this video, we're going to talk about continuity. The definition of continuity is that a function is continuous at a number a if the limit as x approaches a of f of x equals f of a. Okay, so if the two-sided limit as x goes to a of f of x is equal to f of a. So what this is saying is that if you want, if a function is continuous at a number a and you want to find the two-sided limit as x goes to a of f of x, all you really need to do is to take the number a and plug it into f. Evaluate the function at f, at a. All right, and so that's a pretty nice property to have, right? All we have to do is plug in the number a to find the limit. So this definition here says a lot about continuity, and it's a little bit subtle. So in the following slide here, we've got the test for continuity, and this is an important thing to know about continuity, and we'll use this in about all of the problems that we do on this section here. So if you take and pick apart the previous definition and look at all the details, it turns out there's these three conditions for continuity that we're going to look at. So a function is continuous at a number a if all of the following are true. So a is in the domain of f, so that's condition one. You have to be able to evaluate the function at f and get a valid mathematical output. So another way of saying that, of condition one, is that f of a exists. Okay, you have to be able to get an output value for the input value of a. So that's condition one. Condition two is that the two-sided limit as x goes to a of f of x exists. So the two-sided limit has to exist at a. And finally, condition three is that the two-sided limit, whatever value you get with that, has to equal the value of the function when you plug in a, so f of a. All right, so if a function meets all three of those conditions at a number a, then we will say that f is continuous at a. Okay, if any one of these conditions is false, right, then what we will say is that f is not continuous at a. So in the examples following, what we will do is check these three conditions and basically just answer the question, is f continuous at a? And we will just kind of check each one of these off. If any one of these conditions fails, right, then we will just stop the problem, because at that point we would know that the function is not continuous at that number a, and if all three conditions are met, then the conclusion is that f is continuous at a. Okay, so that's what the definition is. First, we're going to look at some graphical examples because there's a definite graphical tie-in with how the function looks if it's continuous at a number a. And then we will take a look at how to evaluate some functions or determine continuity of other types of functions when you only have the formula involved.